Okay, let's get started. Today we are going to do Android PowerPoints. PowerPoints are actually sort of important because then the source code makes more sense. So there's a lot of theory behind the way a lot of this stuff is introduced and done. So makes no sense to show you stuff, but I have shown you stuff already. So what I'm going to do is kind of pick up where I left off on the Google Maps. Show you the text that goes along with the stuff I jumped ahead with, and then talk about location, talk about sensors, talk about networking, talk about a bunch of features that I got to give you the foundational stuff for. And then next Monday we'll go and we'll spend the entire time looking at source code examples. So this is going to be our PowerPoint day, so I can catch up. So this is lecture number 4. I know we haven't got too far. Which is why we're doing this. I'm going to go through 4, 5, 6 or so today. Overview of the sensors and tracking location. We've actually seen the examples already, but we'll take a look at the Google Maps information as well. So these are the goodies. These are the developers that access the goodies, the hardware components that are made available on the phone. And as you may have noticed so far, if you look into the APIs, you see there's this Google APIs. That gives you all the Google goodies. Then there's the basic stuff. And then you'll see in the hardware, you'll see in the API list in the SDK manager, you'll see a bunch of stuff in there. One says ARM, Intel, DroidX. You see all, and most people just left those in. In the beginning I said just leave those alone. Here's where those come in handy. If you have a DroidX with 2.0 USB or 2.0 Bluetooth, you're in good shape. If you upgrade to the newest and latest version, you get a higher upgraded version of the hardware, and the API is not going to support it. The tools aren't going to work with it. Some things are very hardware specific. We're talking about creating applications for a platform that's generic by default. We have different versions of the API, but they all include basic, going to work on all Android devices kind of thing. So far the thinking's been, you just select an API level, run it in the emulator, you're fine. Then we start looking at maps, we go, well, we need Google API for that, we need Google Emulator for that. Oh, okay. And then we start looking at sensors. We go, oh, well, what if the phone doesn't have that? So then, in the beginning, the emulators didn't support anything. No camera support. They did networking though, which is good. Some of the emulators actually the current emulator doesn't support USB either right now, but it does support the camera, which is good. You go out and use the VirtualBox, you can actually download emulators that have different support for different hardware, and then the emulators are created for different platforms. So if you haven't noticed, you'll see one for Asus and for Compact, and there's different emulator for different hardware. So, long story short, on the APIs, in order to get some of this functionality that I'm going to go through today, in order to get that to work, you have to select different project types. And you have to actually select and create something that works with DroidX, or something that works with an ARM processor, or something that works with specialized hardware. Because the sensors and the hardware, so it's driving the application. So the drivers, the APIs, are built to work with the particular information. So here's an example of some of the items that we're looking at. Some of the items, however, from this list are a bit dated because some of the things have changed in concept. As an example here, media recorder. Now we have Google Play Media. So we have M Recorder, M Player. So we have generic drivers and generic APIs that work. And we make instances of objects and they work on everything. Some of the other things, such as the camera, are classes that are particularly created for different types of cameras, different resolutions, different manufacturers. Sensors. So here's a list of some of the features, and what we're looking at is special feature hardware that comes with devices that we write programs for. And so a camera is a class that enables the application to interact with a camera, obviously take a photo, acquire images, screenshots, all sorts of different things. The sensor is the class that represents the get sensor list. So we have a list of sensors that are available on the device. So most of your applications are going to go check to see, get the sensor list, check to see if we have this device. Do we have USB? Okay. Do we have Bluetooth? And what version of Bluetooth do we have? And then if we have it, turn it on. then do something for it. You know, otherwise send up a message that says, hey, nope, sorry, it doesn't work on this phone, something. Sensor Manager is the class that permits access to the sensors that are available within the Android platform. So Sensor Manager is just like Location Manager that looked at the provider in the example I gave you last time. It works the same way, but it works with all the different hardware. Sensor Event Listener, same as before, the interface used to receive the notifications from the Sensor Manager, same as the Location Manager actually. The Event Listener would see, you know, did the location change? Did the provider change? Did something happen? Sensor event, that's what's going to occur when a particular sensor type or activity is detected. Represents sensor events that hold information about the sensor type. Some of the sensors we haven't seen yet is accelerometer, orientation. You know, did the person shake the phone? Did the person drop the phone? Is the person running with the phone? You can actually, there's a lot of sensors on these things. They're very smart devices, and you can write some pretty cool applications that work with it. So sensors on that is sensor. Media recorder. The media recorder stuff has recently been updated, and there's a lot of libraries out there for that. Google Play has actually got a ton of, I'm saying Google Play, I mean something else. It's a Google API for media is what I'm referring to. Geomagnetic fields, the class estimates the magnetic field at a given point on the Earth. So particularly computes a declination from the north, basically your location information. Then we have the face detector, whether it permits the recognition of a person's face. It contains a bitmap, and therefore, you know, look at it, and it opens up, you know, turn on the phone. So. Some of the features are supported on certain hardware, some of it's not. It's hardware-oriented features that I'm referring to. So the sensor type, there's a class that's associated which turns into an object for all of the different sensors and the sensor types. From the generic, and this is now going back to generic, so all phones, all APIs using this will have these particular components, and the components for the sensor types are the orientation, accelerometer, light, magnetic field, proximeter, temperature, stuff like that. Proximity, as I meant to say. There's a lot more actually in the newer APIs, so one of the differences between the newer and the older APIs is the implementation of some of these sensor types and what sensor types are available. Some of them have changed, some of them have improved significantly. We have the sampling rate, which is fastest, gain, normal, user interface, which basically tells us when are we going to look at this? How fast are we going to pool the event? And you can change it, saves battery life. When an application requests a specific sampling rate, it's really only a hint or suggestion to the sensor subsystem. There's no guarantee that a particular rate is going to be available. So it kind of makes applications hard to, and most users can kind of sense this, but it makes it hard to design it, especially, well, mapping stuff's pretty good, it's pretty up to date, but other types of sensors, you know, like shake the phones, and it may not pick it up immediately. Like 5 minutes later, hey, look, I'm going to shake the phone. Okay, and too late now. So it's not exactly 100%. Accuracy, you could set the accuracy to high, low, medium, and unreliable. Why would you want to set to unreliable? You want to save the battery life, I guess. So this particular set of slides is actually going to go through and look at different programs without me having to actually run it through the emulator. So I've got screenshots of everything in here. And this is available by Google, actually, from the Google website for tutorials and stuff. Some of this stuff I can actually kind of skip through because we have already run tutorials and we've already seen. This is kind of generic in terms of slides that I haven't edited it. Probably should, but I'm going to skip through it. We already know we need to use Eclipse and the Android SDK and a little bit of knowledge of this and a little bit of knowledge of that, so we can kind of skip through that. The example in this slide set is going over the same similar example that's available when you download the Google samples for the API, and you create a project using one of the existing samples. And the existing sample was the map view, or the maps demo, I believe it was called. And that I did not go over because I know it was in the slide set, so I'll show you the pictures in here and the code that's associated with it. Last time we talked about maps, and to give you a little bit more information, because I kind of went through a little bit on the fast side last time. I'm just going to summarize. I'm not going to go through the whole thing again, but I kind of summarize the steps that are needed for this. And it's not a bad idea to do this only because we only have to do it once. And you save the code and you use it in all your map views that you create. And the GUI requires it. So the API key is required to integrate the maps into the Android application. The API key is generated from a code. So you locate the SDK debug certificate. It's an actual certificate that's on your phone. Excuse me, that's on your computer. Actually, when you sign apps, you sign them with a digital certificate as well that you create from your computer that says that it came from your computer. So you locate the SDK debug certificate, and as I mentioned before, it's going to be in a different location if you're on a Windows machine versus a Mac machine. If you're on a Windows machine, it's going to be in the Android directory from application data, perhaps, maybe, depends on where you put it. And the file name is always going to be called debug.keystore. And I showed you the file actually from my system on Monday. And my system, it was in a hidden folder, which is kind of new actually. It never used to be hidden, but now it's hidden. For security reasons, I guess. It's a certificate. So this certificate actually just give you a little bit more information on it. The debug.keystore is what's used actually to sign your application, so it knows it came from your computer. And it's generated from the hardware on your computer, which is kind of interesting. So it's a way of identifying you. So you copy, or you just leave it there. I didn't copy it, I just left it. But these instructions are kind of generic. You can copy it in the Android directory if you want to move the location. Open the command window, navigate to it, and you're going to type in, from the bin directory. You already have this thing called a key tool. The key tool comes with your Windows version, with your JDK. Excuse me. It comes with JDK, which is the Java program, Java SDK. All of the SDKs, JDKs for Java, contain this key tool. You use the key tool to generate, so it executes the following code to extract the MD5 fingerprint. It's the MD5 fingerprint from the debug key store that is used to create your key, your app key. And your app key is only used for maps. So you can have a generic file that's stored somewhere that just holds the key, and you cut and paste and put it in. No one remembers what the key is because the key is too long. The key is like really long. So here's an example of the syntax that you run. You just cut and paste it, put it in, type it in, and it generates the MD5 certificate fingerprint. You go to the website, you paste the fingerprints, long code into the website, you press OK. Has anyone done this yet, actually? Nobody's done this yet. You're all afraid to? Try it out. Maybe this lecture will help you as well. So, yeah, I can't do it for you. You got to do it yourself. I can't give you a key. You have to do it on your own computer. Otherwise, your maps aren't going to work. So, copy it in, cut and paste it in. When you get it back, you'll get that little thank you, and here's your key code. Just do a save to PDF or a save it, print it. You don't want to print it out because you want to be able to cut and paste it. So if you don't have anything to save the output screen, then just cut the code, put it into Notepad. Make sure you don't have any extra characters with that. If you put it into Microsoft Word, you're going to have extra characters when you cut and paste it. So just put it into like a text editor or something, if that's the case. Or save the printouts if you can. So that's basically how you're going to get the map key, and that's basically how you're going to be able to run map programs as we've seen last time through the example. So normally I would show you the example right now, but we've seen the example already. So I'm going to skip ahead. And so, oh, there we go. So my PowerPoint actually starts working again. Oops. Sorry about that. It's not exactly what I wanted to do. Computer's running a little funny right now. Here we go. So we create a special AVD, if you remember before, that runs the particular Google Maps from the Google APIs. You cannot use the same AVD as you've been using for Hello World and some of the other programs that you ran. And to do this, you would follow through some of these instructions here. We've actually did this already. We demonstrated how to do it. And the next project is in this particular PowerPoint slide is going to go through a generic thing that we've actually already seen, but I'm going to sort of review it only because it's another opportunity to point out anything I may have missed when I first showed you the examples on Monday. So you would generate your map key, save your map key, go into your Android system, create an AVD to run the Google API, because that's your first indication whether or not you actually even have it. Because you have to create a new project. When you create a new project, you're going to use that Google API as the type. So if you can't create the AVD, then you can't create the project either, because you don't have the Google API installed. So it's a big red flag right there. So I would start with the AVD, make sure you've got that. If you don't have the AVD, no option exists. Go into the the Android SDK Manager. Click on and download anything that's not installed. Only do it for the version that you're going to run it with. You don't have to do it for everything. Once you have the API installed, you create a new project. So you go in, you used to go project new, and you create, in this particular case, if you're going to run through, and this is actually workable code that you can do. You can cut and paste it out of this lecture, as lecture number 4, put it in to Eclipse, and it will run for you if you have an API key. The project name is going to be called GPS Simulator. If you want to do it this way, you can. Otherwise, you can run the demo. The map demo is going to do the same thing, actually. It runs the same program. But this was back with Platform 1.5, which didn't actually have the map demo. So instead, they just put this in the map demo. Enter the project name, enter the package name, enter the activity name, finish the project, and you have the project. We all know what projects look like right now. And we all remember we also have to add permissions for GPS. In this particular program, we don't actually have to add the permission for the internet because our GPS simulation doesn't even use the internet because it doesn't actually have GPS capabilities. We're kind of faking it through the DDMS if you were here last time, the debug that works, the window that works with the emulator that's going to actually control it, that's going to give us our functionality because we don't have GPS functionality built in there. So we add permissions for GPS. You need to do this for all applications that are going to use the GPS. So you modify the manifest, you click on the GPS simulator project, you go into the Android manifest, and you add, and we showed you last time, it says uses permissions, and you would add the permission to access find location. You can actually access course location as well if you wanted to. And you can also add the internet if you'd like to for modern day applications. So it just gives your user many different options. So the add location manager is used to get the location updates. Location manager is the service that runs, or the location is the service that runs. So this is similar to what I've showed you last time, but to go through to show you the different components. In order for the service to actually be functional, you got to know where you're at. So in order to know where you're at, you have to ask the location manager. In order to do that, you have to make an instance of that object so you can go out and ask it. So we've got location manager LM, which is going to be our reference to the location manager object. And we have a location listener that we're going to create that's going to listen. Because once we get it, great, no problem, we have the location. What if the user moves? So you were in your car and now you're down the street. So we have to listen for changes if we're going to create a map program that's going to be functional in terms of location. So the onCreate, this is the same as before. The onCreate is going to create an instance state, lifecycle, set the context of a domain, no problem. So we're going to use the location manager to obtain the GPS location. So LM, which is our location manager instance, equals location manager get system service context location service. So the basic API hasn't changed since 1.5. It's still the same. It's still the same service, still the same API base actually. So location listener is going to be equal to new location listener. So we're going to basically create a listener, create the location, create an instance of location manager, and then on the location manager request location updates. And then this is where we're going to use the GPS provider. And this is a simpler example than the one I showed you actually, because the one I showed you we created a provider instance, and then we created a location manager instance, and then we created a service listener, and then we put all 3 pieces together. This is actually incorporating it all together. So the GPS provider We're not really dealing with the provider at this point. We're just basically asking of the provider, give us updates. And the provider is going to be, and I showed you this last time actually, one of the options that is turned on in terms of the settings on the phone. So it might be GPS, it might be the internet, it might be Google something or other. I can't remember what it's called. So on the listener, we have the My Location Listener that implements the location listener. So we can listen for different locations. On location change is one of the methods that's implemented in. If we remember this right, this is an interface location listener. And the listener itself is going to basically give us the information that we need in terms of the longitude and latitude. And then on the updates, on anything that's changed, then it's going to update our information for us. So put up a toast message that says essentially location changed. The latitude is now this, the longitude is now that. So if you cut and paste this code and put it into a project that you create, and if you have a phone, take the API, actually APX file, copy it onto the phone, run the program on the phone. Take the phone, walk down the street, and you go longitude, latitude. It keeps changing. How often is it going to update? It depends on how you've got the settings set. If you use the defaults, it's going to be reliable. But if you go back to that other slide I showed you a few minutes ago, we have those options. This is where the options play. In the user performance, how often is it going to update? How often are we going to check the provider? So, on a provider disabled, do something. On a provider enabled, do something. These are just the interface implementations that are required. On a status change, do something. We don't really have any code implemented for it, but we have to include those empty methods, by the way, because we've implemented the interface, which means we have to implement all of the methods that are associated with the class that we are implementing. Okay, to test it in Eclipse, you have to switch on the DDMS view, and we've seen that actually. So I'm catching up with the PowerPoint to what I showed you already. The perspective, if you remember that button on the right hand side, you switch it over to DDMS so we can send information back and forth. We find the location controls in the Emulator control tab, which is toward the bottom, if you remember that. You don't actually have to do this anyway. You don't have to click on the GPX tab. It's on for us automatically, so just leave it on whatever it happens to be on. Locate and select volume. You don't have to do that. Click play to begin and sending recordings. Actually, you click send now instead of play, and you send it coordinates. Here's the two lines that get added. We have the Google Maps library that we have to add, and the user's permission for the internet. If you set the permissions for the GPS and find course location or find the find location options, I would just put the permissions on for the internet automatically. In fact, most applications that you create are going to use the internet one way or the other. So it's not a bad idea just to put it on. Unless, you know, for instance, you're creating an application that's like a game or something like that, or, I don't know, something that you don't think is going to use it. But in essence, what we're looking at is the manifest. You can cut and paste this manifest file and put it into your manifest. This is actually working on a 1.5 API, so you can probably update the project properties, so make sure that you have that correct. And in here, we're looking at the uses library, which is kind of an interesting thing here. If we put it here, then in the XML file, we can just create a map view. If we don't put it here, then we have to go com.google.android.mapview, maps.mapview, and we have to preface the location of this. So this is sort of like, you know, putting the package at the beginning of the class file. If we put it in the manifest, then in the XML user interface, we can set it and not have to preface where it came from. There's a couple more Google libraries actually outside. There's media library. There's maps library. It depends on going back to that first couple of slides I gave you. There's the camera. There's all the hardware devices that come with the Google APIs. You'll have to use the library, and you have to put it in the manifest to say, we're allowed to use it. This program can use it. Kind of thing. And then we have a couple of intents in this particular program. It looks like we have an intent filter, so we're gonna register the main program. And here's our layout, and we don't have to do this, but this is in the slide to illustrate the point. If you don't put this in the manifest, you don't want to modify the manifest, you can just use the word map view here, actually, if you put it in the manifest. If you don't put it in the manifest, you have to do this, actually. This is just basically telling you we're going to use a map view component. And the map view component is, this is where you're going to put the API key. So the API key that you spent all that time getting only goes in one spot. It only goes in the component that you're putting in the UI, the map view. The map view is the only thing that uses it. If you leave it out, the program will run just fine. The only problem is you won't see the map. The screen will be black or white depending upon your API version. And you won't see the map. So if you don't see the map, then you know there's an issue. Wow, this is small code. This is the main class that extends the activity class, and I apologize, it's a little blurry here actually. This is not in text, it was actually a screenshot instead that was put in here. And we can see all the pieces put together, and we actually looked at it already. This is just the big rest of the code added to it. So we saw the location listener, we saw this part up to here. This is the new line of code. It's the map view that equals the map view find location, find by in the resource.java file, essentially. Create a local reference to this map view, and the map view is up here. It's a private map view. We're also going to have a map controller called MC as a reference object for that one. So mc.mapview.getController. So the map view's got a controller. It's got the plus and the minus, and it's got all of the different things. This is just one more. Instead of creating a controller object, we can create and run the get controller from the map view. Instead of putting it on top of it as a separate object, we're just running it, creating it from the object. Whoops. Hello. There we go. My mouse was misbehaving. And then this is the code we saw before for the map location. Not quite sure what's going on here. It doesn't like the zoom. This is the code we saw before for the map location, map listener, excuse me. So it's just basically a repeat of this code I've seen already. Alright, so if we run it, this is an old emulator, so you're looking at an old picture, but we did this live last time. So what we did last time was we found the emulator in the device list. If you don't click on the right emulator, you're not going to be talking to it. If you don't click on an emulator at all, you're not going to be talking to it, you're going to be talking to yourself. So you click on the right one, and then you go down into the window underneath it. It says Emulator Control. And in the control window, that's where we sent the SMS message, if you remember that. And we set the GPS coordinates for latitude and longitude. So it's just a little bit of review to catch up with that. So that's what we did last time, and I was supposed to cover that PowerPoint before we did all that stuff. So we sort of saw it in reverse order. This is the new stuff. So, as I said on day number 1, Android platform is a Linux platform. It's basic Linux, Unix. In fact, we have basic Linux, Unix processes that run, and we have IP that runs on it, and TCP that runs on it, and interneting protocols that run on it. And we can actually run UDP and TCP and all of the other things associated with internet working on it, which is nice because we can write applications that make the phone communicate like a server or like a client to run with other programs. As an example, you can easily write a program that does chat or instant messaging by talking to an internet server, or using UDP instead of the HTTP protocol to go and log into a server, and the server could be any server, any provider out there. Download messages, upload messages, share information between users, do all sorts of networking stuff. So the internet is based on a layered architecture called the TCP/IP stack. This is not a networking course. I'm not going to go through the OSI model and the TCP and UDP and all that stuff. But if you're familiar with it, this might actually make some sense to you. From the linked layer through the internet layer, through the transport, through the application layer, this, if you were taking a Unix course, this would be identical. So the point of this slide is to tell you that it's a Linux box. It's a baby Linux box, has the same support for Unix networking. So the same stack exists. So the application level is controlling the data. We have the transport level. We have UDP. We have TCP as well, although it's not on the slide here. The internet layer has the IP data, and the link layer has the frame route, frame data, frame header. All of the information that you might find in the regular OSI model and the 7 layers of the stack exists on the phone. What does that mean? We can take applications that are written for computers, Linux computers, and port them over to the Android phones or tablets. And it makes it easier for development, actually, because the information is the same. So server machine is identified on the internet by some form of IP address. Each phone has its own IP address that's assigned when it makes an IP connection. Same thing as in a regular Unix box or Windows box. You can actually set static and dynamic IP addressing on most Android devices. Daemons are the processes that are running in the background, which listen for all the time for connections and requests from clients and particular ports. So you can create an application that does peer-to-peer connections using regular old Linux stuff that takes and goes from one phone to another phone. So you can send a picture to your friend or something like that, or send a picture to using the IP address, just the same way as you'd send chat messages back and forth or broadcast messages to other Unix boxes or terminals. So once a connection request comes from the server on a particular port, corresponding daemon can choose to accept it, establish a connection, or reject it. By default, most most settings have all of this turned off. And you end up turning it on when you want to use the internet because your web browser doesn't work, or when you want to install this chat program or something, this new app that you have on your phone. So an application layer is typically used for a client to get and send data to a server. So just imagine the concept of inter-processing, inter-networking, working on a phone the same way as it does on the Unix box. Not really going to get into very much of that because this is not a Unix class, and it's not really a networking class either. So I started this lecture last time, got halfway through it. I just want to see if I missed anything. I'm just going to take a quick look at it, see if there's anything in here I didn't cover for you. We talked about longitude and latitude. That's what's basically giving us our location. Talked about where we are. We talked about how to go out to the internet to find the longitude and latitude. You could probably build your own program for that. Talked about the API. Won't run without the API key. These are the three: the access course location, access find location, and the internet. These are the three that you're going to need most of the time for every single mapping program that you're going to use. You may or may not necessarily need the internet. Depends on the service provider. If your provider on the phone is the Google Map Services, you're going to need the internet. So if it's GPS hardware, you're not going to need the internet. Manifest also needs to specify the map libraries I mentioned before, the com.google.android.maps library, and actually has to specify as needed. You'll find that the manifest can also specify to use other libraries as well. You put all libraries that you're going to use from third-party APIs that are not part of the standard SDK, you put them in the manifest. And you say uses-library instead of, something else. In the map API key, we went through that, referenced in the layout. It's referenced in the map view object. Let's see. Directions for routes. You can actually get at the direction services, believe it or not. You don't have to reinvent the wheel. Every phone has a map view program that does locations, that does directions. You can actually tap into that, make an instance of that object, and use that functionality, which is the best way of doing it, actually, because then you don't have to write your own. The location listener and the updates, the map, we actually saw this live, and I just showed it to you in a PowerPoint, in a different PowerPoint a few minutes ago. So it's about as simple as it gets. We talked about the DDMS, we actually saw that live. Geocoder library. Don't have to use the geocoder library. Don't need that anymore. The location manager gets you the geolocations. In terms of other hardware support for the phone, can't use external Bluetooth GPS devices with Androids. With the emulator, you can use it. Earlier APIs, however, and this is the other thing, another word of caution, depending upon which API version you're using, you want to use above 2.0. You want to use like 2.1, 2.2, because earlier versions of the API didn't support Bluetooth, and they didn't support USB, and they didn't support GPS. And the emulators never supported cameras up until the current ones, 3.0 and above, I believe. So this is, you can't use Bluetooth device for location determination. You still can't use Bluetooth device for location determination. That's still the case. I'm sorry?
There are some apps which do that function.
Yeah, there are some apps that have added the functionality. Yeah. It's not built in though. You have to actually. And another thing as well is you can actually import and use in, and this is the other thing I didn't mention. When we modified the manifest to use the Google Android Maps library, any third-party library can be imported this way and used. So if you have a Bluetooth map location library, which is available actually, you can load it into the manifest and use it as if it was part of the regular old API. The current, I believe this is wrong because I believe 3 or 4, maybe as soon as 3, incorporated it. So, or maybe it's 4. I don't know. I was reading some article on it recently that said it's now in there, and I think it came along with the camera support, the same version. I'm not quite sure which version it was. So, there's so many different versions. Yeah, that works on the emulators. Yeah, it uses the camera that's on the computer. 4.0? Okay, that's when they added the Bluetooth support, I believe. And what is it, the ice cream version or something? I don't know. You know, there are so many versions of this API. And, you know, I was thinking, you know, oh, maybe the iPhone did. We're up to 6 beta right now on the iPhone.
They're named after the deserts.
Yeah.
Like, starts with eclairs, froyo.
Yeah.
Gingerbread, and then ice cream.
I think that people over there have a sense of humor. I don't know. Or they're just bored and creative. I mean, anything's after deserts, you know, anything's after... Anyway.
The next one is called Jelly Bean.
Jelly Bean. Jelly Bean? Where do you have the next one out? 5.0?
I'm not sure.
Oh.
Probably 4.2.
Well, we're up to 4.03, I think, right now. 4.04.
4.04.
4.04. Wow. Last time I updated my computer was 4.03. Well, now we have iPhone SDKs out too. It's in beta in the 6. I just got used to the 5. Now we have the 6 out.
No, they're yet to launch 6.
No, they haven't launched it yet. It's in beta. If you're an Apple developer, you get to try it out. But I can't update it because everybody else is using 5. So, okay, summary: maps need API key to display. Maps need permissions. Maps need API enabled. Actually, lots of work done over the internet. The older versions of the map key, actually, you need the internet to use the maps, whether or not you're using the location manager is using the provider from the internet or if it's provider from the GPS, you still need the internet enabled to use maps because that API has to authenticate the key in order for the map view to show. And it's done through an internet connection. So you do need the internet for all map programs. Moving right along to newer and better things. Hello. More networking stuff. This is a different program. It's actually going to download from the internet something. So we've seen how to connect to the internet. We saw how to create a web view. We saw how to create a web browser. We created one using just a URL and the web view object. In this particular lecture, we're going to look at downloading, not necessarily using the web view, but accessing the internet and using the networking components. So, just to reiterate the point, we have some required packages. The required packages are actually included automatically in the API. Android.net, Android.net.http to actually access the internet through SSL certificates and things of that nature. The Wi-Fi, net.wi-fi, and telephony. So I'm not going to read this so you can actually download this and take a look at it for yourself, but or go through the developer.android website. But we are running Apache actually. It's Apache compatible because, again, going back to the comment I meant about being a Linux box, it's running Apache. So the TCP protocols, the IP protocols, the HTTP connection, all of it's the same. We can do a post, a get. You can actually create a website, put it on the phone, and have it run like a browser actually on a computer. And a lot of apps are actually kind of built that way only because that makes it compatible with web apps and things, other devices as well. So this is the program that we actually went through to refresh your memory on this a little bit, because I wasn't supposed to show you that yet, but I already showed it to you. So we put a button on here, and this is in the main XML, and this is a web view that we put on here that's going to show us essentially a website when we press the button. And on here we have, oops, to view the object by the object ID. This kind of goes backwards a little bit because we've already covered most of this stuff. To get to the button functionality in the activity class, we're going to create a local reference object for the button and get the reference ID for the button in the r.java file. And then we're going to click the we're going to select the on-click listener on the view, because as we know, the wrapper for the entire GUI is a view element. So the interface definition for the callback, that's going to be invoked on when the view is clicked. So on the click, we pick up, well, which view was clicked, and then we call, the function that's going to be inside of this particular method to perform the actions that are going to be associated with the click. And the strings library here is going to have the two strings that we're going to use for this particular sample program. And again, as I mentioned before, you can take and cut and paste this code and put it into an Eclipse project, and it will compile and run just fine for you as well. And this one's not going to require the map key, however. This one will work because it's just using the internet. We do have to set the user's permission, and we have to actually add the internet. We've seen this before as well, so we would have to do this if we were creating this application. And this application is essentially putting up a web view, and it's going to show a web page. We can have it download an image. We can have it send an image. We could have it do anything we want functionality-wise that's associated with the internet, or actually we can combine it with other functionality. So if you're using the emulator, then you do have some limitations. Each emulator instance of the emulator runs behind a virtual firewall service that isolates your development machine interface. So you can't send, long story short, you can't send from the emulator to the host computer and back and forth. However, if you use VirtualBox and you load in you install the ISO and you create a directory, actually it creates it for you automatically, and you have all the files located on the computer because it's installed inside of the virtual partition that you created, you can actually transfer from the internet to the computer. Can you get viruses this way? Highly unlikely, because there aren't that many viruses that come through Android phones at this point. And I'm waiting for virus protection to become a problem. So, have you heard of any viruses? I haven't heard of any virus activities yet on mobile devices, but computers were around for a while before viruses were hit, so. The next greatest invention is going to be the virus for the Android phone, for the internet, for the iPhone. Actually, probably come out on the iPhone first, I would think, but Apple doesn't have any viruses, so, or computers in general. Although there's virus protection for Mac computers. There is no virus protection for mobile devices right now because there's no viruses. So, but this protection, however, this firewall/router protection that comes through the emulator, is only a problem for emulators that are being, if you're using the built-in emulator, if you're using a VirtualBox emulator with your own installed, you can potentially, if there were viruses, you could potentially install one through the phone, through the emulator that was emulating the phone. However, highly unlikely. Long story short, you can communicate and you can share files if you have the VirtualBox set up and you have the ISO installed into the directory. Communication with the emulator device may be blocked by a firewall program running on your machine. It could be, could not be, depends on which emulator you're using, long story short. So behind a proxy server, if we use one of the emulators and take a look at, this is an older 2-point-something emulator, and we go into settings, your device is going to have different, and this is the same as mimicked out of the actual device itself, and I believe this is like a 2.0. We have wireless and networks. We can actually turn these things on and off through Android phones because we can get at the settings and we can get at the, turn wireless on, turn wireless off type thing. And if we do that, we could essentially make a virus, I guess. Not to focus on the concept of virus creation, but you could write, I can definitely see writing an app that takes and opens up the wireless, turns on the wireless protection, turns on the wireless access. Takes and looks at your address book as an example. Your content creates a new instance of the content provider, looks at the contacts, copies them into a text file and then sends them out onto the internet somehow. That actually, I can write that program for you. It's pretty easy, actually. But why would you want to do that? I don't know.
Before installing the app, the phone actually asks for permission.
That is an excellent point, but who pays attention to that? As I was saying when I went over the lecture on security, Android security, I mentioned, you can use this, use that, give access to this, give access. You can turn everything on, and when the user installs your app, it says, in bold red letters, it says uses the internet, uses Bluetooth, uses this, and some users would actually pay attention to it, I believe, and say, this program that B. Hacker wrote that says send my address book to the world uses the internet. Do I want to let this on? Well, if I called it that, probably no one would install my app. But usually people go, oh, it's Angry Birds. Sure, I want that. I want that app. So you put it out there, but users go, okay. So they did their job. They told you that that was going to happen. So, but luckily for us, and I don't know, as soon as I say this now, we're going to see on the headlines there's going to be a virus that comes out. One of you guys is going to write it, but long story short, the protection's there if you pay attention to it. But if you pay attention to some of the things, in fact, if you watch when you install apps, almost every app turns the internet on. Almost every app turns something on. Sets a permission for something. Allows you to look at your contact list. Allows you to do this, allows you to do that. And what choice do you have? You can't install the app if you don't say okay. There's no install it and turn all that stuff off. So I don't know, for development it's kind of tough. You're stuck between a rock and a hard place, so your user's going to accept it. Some users, believe it or not, don't even read that. They just go, okay, okay, okay. And you probably have never even seen that screen before. But install an app. Next time you install an app, take a look at, see what permissions are being turned on, and you'll be surprised. So you can see the content provider. That's your contact list. See the internet. That's what's going to send it out to me when you install my my virus. Let's see. So in here we can look at mobile networks. We can do access point names. We can look at proxies, port, username, password. We can actually access everything. Everything's behind a proxy server on the phone. But again, servers are servers. You actually have a firewall. You actually have a proxy server that's installed in an Apache environment on every single mobile phone. And you actually have the ability to communicate just like you would have in Linux and Unix. Just go back to that point. So set permissions. If you're going to turn this on, you add the permission to the Android manifest. You add your permission internet. This opens up the phone to the internet access. If you were to write this program essentially is going to download a file from the internet. So instead of showing you how to upload a file, I'll show you how to download a file. And it's not going to be your address book file, it's just going to be a JPEG file. So you would import, this does not use the browser, by the way. This is using the internet access. We've already seen how to load a web page up there. We just create a new web view object and we send the URL to Google or whatever we want to. We can load a website. So this is using internetworking I/O. And these are the same libraries, by the way. You can write the same program, by the way, to work on a regular old Java application that does not run on an Android phone. It just runs on a Java JVM. So we're going to put on, we're going to import libraries for I/O input stream. And if you're in the Java class, I'm going to talk about this on Monday, actually. So I haven't gotten there yet. I/O exception, HTTP URL connection, URLs, connections themselves. The regular old activity, the bitmap, stuff like that, bitmap factory, image view, text view, toast, bunch of imports. So we're going to write an open HTTP connection. So this is not using a web browser. This is an application that's going to access the internet, get a file, download it, and show it in an image view on a phone. So you open up a connection to the HTTP server using open HTTP connection. This is the same method, the same object that you're using in a regular old Android program, actually. Excuse me, regular old Java program. You first create an instance of the URL class and you initialize it with the URL to the server And then when the connection is established, you pass the connection to the URL connection object. and you check to see if the connection is established by using a HTTP protocol, just to check to see if we're successful. And then the URL connection object is then cast into the HTTP URL connection object, and various different properties can be set. You can actually check to see, is the connection secure? I don't know, is the connection open? Certain things about it. Next, you can connect the HTTP server and get a response from the server. This is web development. This is send and post and receive request. So you can request a response, come back to the HTTP response and look for OK. And then you can get the input stream object from the connection and begin reading the input stream data from the server and start doing something with the data. So the function then returns the input stream object that's obtained and puts it out onto to the screen, or writes it to a file, or does something to it. So here's the code that we would write, and you can cut and paste this code and stick it into an Android, or actually not even an Android. You could actually put this into a regular old Java application. And if you heard earlier for the Java class, you would create an icon, image, object, component, JComponent, JIcon, stick it on the screen. Run this code, stick the JPEG file into the icon file and put it on the canvas, put it in the JFrame. So here's the class for HTTP download extends activity, because we're on an Android phone, and the usuals. Got the main from the layout. We're going to set the context via domain. Then we have a class for the input stream as the data type. It's going to open the HTTP connection, and it's going to throw an IO exception. And the exception handling on the Android phone is the same as it is in regular old Java. So the input stream IN is equal to null. Set the string to null, say it's empty. That way we can check to see if we got anything from the connection. Set the response to -1, so we can do some error checking on that as well. So we can set it to 0 or something if we get it. And then create the new instance of the object for the URL. So it equals new URL with the URL string, which is going to be the URL that you're going to try and connect to. And then URL connection object here, name of the object, we're going to call this con. It's going to be URL.openConnection. So on the URL, we're going to say open the connection, basically go to that, open the port. If it's an instance of if con is an instance of the URL connection, which means it actually works, it contains a valid URL address. Otherwise, throw an exception, not an HTTP connection. Like you don't have a connection, you don't have the internet turned on. And then do a try and a catch, and the try is going to be on the connection object itself. We can set the HTTP URL connection type to the connection object, and set the allow user interaction to false. So the user can't really do anything. It's the program that's communicating through the HTTP port. Set the instance followed redirects to true. Set the request method to get. So you're basically running methods for HTTP. If you're not familiar with web development, this is makes absolutely no sense to you because you don't know what HTTP is. But HTTP is a protocol that is used for internet connections through web browsers. So if you're a web developer, you know how to do posts and gets, and you know how sessions, and you know caches, and you know cookies, and you know all the terminology that's associated with it. Imagine you have the same library of function through the Java API for HTTP objects. Okay, so you're going to basically connect to the port, listen, get it. So once you've connected, you'll listen, get it, which is basic code that you're going to do in order to make a connection. This is not using a web browser, going back to that concept, but to make the connection to essentially provide the functionality. Oops, here we go. Then you're going to modify the XML file. And in the XML file, we're going to put an image view out there, because we're going to go connect to the internet, download a file, image file, and put it in the image view, which is pretty cool, actually. I was like, where did that file come from? Some website out there. So we added something to the phone, but we have a firewall, so we can't really do anything with it. So we're setting the orientation on the linear layout. We have an image view on there. We have a text view on there. Text view is going to say something about the image. It's going to show up next to the image or close to the image. So same old image view that we've seen in other examples. So nothing really new about that. So step number 5 is writing the download image method. That's actually going to take and get the image and write it to the phone, or write it to the phone. When you download anything, because there is the protection on the phone, it goes to the SD card. If you do not have an SD card in your emulator, if you don't have an SD card, and this will work in the emulator by the way, on the phone, you can't download anything. Most 99.9% of all phones and tablets have SD cards because that's where the memory is being stored. The emulators, by default, the SD card is turned off, so you have to turn and create an SD card image. If you do that, make it 512 or 256 in terms of the size. If you make it bigger, you're actually reserving space on your hard drive. That acts as a virtual SD card. If you download items to the virtual SD card using the emulator, no access. It's stuck in the emulator. You use the virtual box and your own Android emulator. Yeah, you can actually get at that information. So you can use the emulator to download, manipulate files, and actually look at it on the SD card, which is the virtual hard disk, essentially, that's stored on your computer. So in step number 5, we're writing the downloaded image. So we have a function called download image that we're going to create in the sample program that takes a string containing a URL of the image to download, then it calls the open HTTP connection, obtains this input string object from reading the image data. The image stream object is then sent to the decode stream method of the binary bitmap factory class. Bitmap factory class is what's sending the information, essentially to create the bitmap image. And then the decode stream method decodes the input object into the bitmap. And this is all done automatically. It sounds like a lot of work, but it's actually 1 or 2 different method calls. And then the decoded bitmap is then returned to the download image button or functionality. So here's all that stuff in the code. So it sounds like a lot, but it really isn't that much. So here's our bitmap, and this is the name. This is the type of the method that we're calling, and it's download image, and the image takes on a URL. So we go to the method goes to this URL, downloads the image, essentially. So we have an image, we have an input stream, reference object. We try through the open connection. We run it. We run the decode stream on it to actually pull it back out, put it into a bitmap format, and we return the bitmap out of this. So. And now to test the functionality, we modify the onCreate to actually call the method. And in the onCreate method here, this is a streetcar.org minimum. This is going to download a cable car picture, actually. So the image, reference image view. So we can write to it. We can say the set bitmap image to bitmap image, and bitmap image is going to take bitmap that we've downloaded. So we run the download image method, and that's download image method is the one that we created in the previous slide. That goes to the URL that's indicated. This is the method here that I just gave you. So if you cut and paste this and put it into an Android project and you run it, you get this. Not a web view, by the way. This is an image view. And in the image view, we have a downloaded image that came, and this is the text on the top that just says Hello World HTTP download. I just tried out the code recently, and actually the code works just fine on the current API as well. And you do have to make sure you have the internet connection turned on and that you are using a correct URL. This URL, believe it or not, still works. This cable car image is still at this location. So you can actually use this if you wanted to. However, you can probably use it for something else if you wanted to as well. So it basically demonstrates the concept of being able to use HTTP through an internet connection to download something. An image. What about downloading a file? So you can actually sort of create a, an FTP program if you wanted to. You could take, as an example, attachments from emails and then send them to other people through file transfer. You can, in this particular case, use the HTTP to download images and web content, doc files and PPTs and stuff like that if you wanted to. It's basically file exchange, internetworking connections, all done. Simply using the same set of libraries, the same set of tools. So it makes what used to be an extremely kind of complicated environment, it makes it kind of simple actually. Java is pretty easy that way. If you were doing it in C++ in a regular old program, it would be more complicated. I only have one lecture left, so hold on. Android storage. I didn't start this, did I? Did I cover this lecture? I don't believe I did. This is the other one I need to catch up on. I started a little bit late. That's why we're running a little bit late today. I want to talk about Android storage because this puts all the pieces together in terms of all the different concepts I've given you so far. Several different options to store data with the Android phone. You can put data in preference files. You can put data into normal files. Everybody remembers files from programming. You know, you had a program and it saved all your settings in a file. Program loads, opens up the file, loads the settings. Program closes, saves the file. Files are used a lot actually for settings and things. Only problem with files is that they're per app. You can't share the files among different apps. Preferences you can set and use over and over again. You can also get at system preferences and stuff like that as well. And I'm going to go through the differences between those in a few minutes. You can also send data across networks to a service, as I mentioned before when we downloaded that image in the last example. It was a way of getting information from a different device, from a different server. You can also use a database. So here's our lightweight option, preferences. Preferences are fairly easy to set. You can put data into a preference file. So you create or you call the context get shared preferences to read and write values as key value pairs. So your program could have a difficulty level. You know, it's a brand new game you just developed and there's novice, average, and advanced. And every time the user comes into the program, they go back to novice. Ooh, they don't like that, so they want to be advanced. So you can set the preference to advanced, and then when I go into the program, it reads the preference file and says, what is it set for? Advanced. Okay, so it makes everything, you know, look and feel the same way as it should be. This is the same thing you get, let's say, when you set things for your Google or your Yahoo homepage or something, you know, your colors, your fonts and stuff. So you use the activity.get preferences with no name to keep them private to the calling activity. So they're not shareable across applications unless you expose them as content providers. So if you create a content provider, this is where going back to what I said about the viruses. Your contact list is part of the content providers. You can actually make your own content provider and put your own content out there. And all applications can use it. So content providers as a concept is the ability to share data between multiple applications. And one of the things that you always share on a phone is your contact list. You know, your email addresses, you know, all that stuff is usually shared between applications. Content providers for built-in services, there's restrictions that you can set. So you can't modify, you can't delete, you can't destroy, you can't copy, which makes it protective. So I don't know if my app really would have worked, because if people were smart enough and they set the defaults to, and my app should have maybe perhaps set it so it wasn't writing any content providers. You can still read it though, and I can still copy it. You know, so depending upon how the security the environment is set by the user, partly the user is partly the app, because the user can turn off the internet, and then the app can say, hey, your internet's turned off. Would you like me to turn it on? Okay. Oh, your content provider service is turned off. Would you like me to turn it on? Sure. Okay, now I'm going to send all your contact lists out. But it's the ability, in a nice way, the content provider shares the information. So we can write larger data files as well. And we can keep the data files with the program if we don't want to use the content provider. So you can only access files that are available to the application that are delivered with the application. So if I have a program like my address book or something, if I save them in data without using the content provider, without exposing it to the rest of the apps, I could secure it. I could make it into a special content provider that only has certain access, or only allows certain things to happen with it. So you can either write to a new file or to a pre-included file under the system raw my data. As an example, this is just the name of the file, my data. By default, you don't have this directory in Eclipse. Actually, you don't have the menu directory either. So in the resource, you create a directory called raw, and you put your text files in there. Actually, you could put Word files, HTTP files, HTML files, I'm sorry, PowerPoint files, doc files, anything you want, any file you want, anything that the application is going to use. And it's like putting it into the home directory. So when you load the app, when you create the application, the APK file, and you take it has that file inside of it already. So you're installing it with the file. So you can read data from the file, call context.open file, and I have an example I'm going to show you on Monday when we start looking at source code examples. It's going to show you the read and writing to files. And then I also have that example that I showed you. I cut and pasted the code and I put it in an Eclipse project so you can see the image download to the to the phone. You can actually kind of see it work. You can pass it the name of the file. It returns the standard Java file input stream object. It works same as regular old Java file I/O. So to write a file, you can call the context open file output with the file name, and it returns the file out. Actually, a program can write files as well. It can write to the file that's in your project directory or in your app directory. It can also write to the SD card. You have to turn on the SD card privilege in order to write to the SD card. Most people, actually, believe it or not, most people don't even look at those. But if you've ever looked at the content of your SD card, that might be an interesting experiment for you to do. Hook your phone, after you've installed a bunch of apps and used a bunch of stuff, hook it up to your computer and see how much garbage is on that SD card that's left over, because nobody cleans it up. They just write to it. Write to it. Oh, I had temp file, write to it. Preference file, write to it. Oh, I uninstalled that app years ago, but I still got the preference file on my SD card. It takes up space. You know, unless you got like a 32 gig SD card or something, you know, you're going to run out of memory eventually. And if you are running out of memory, you clean off the crap off of your SD card that applications have left. Because you've opened it up, you've let them use it. So, if you have, that is. Okay, so writing larger files, writing files that get shipped with the app, writing files while the app is running, we'll store it in the app space with the file. You can place data elsewhere on the network, as we've seen before. We can use web services to store data elsewhere, like that JPEG file that got downloaded and put into the image view. You can make this automatic or at the user's discretion. Twitter apps, photo capture, all sorts of stuff you can be shared with apps from internet locations. In fact, you can take all of your photos from a particular site and download it to the phone if you wanted to. Or instead of downloading it to the phone and filling up that SD card, you can run it from an internet location. So a lot of videos and things like that are not stored on your phone. They're accessible through the HTTP protocol. You can also have persist data in the database. All right, so here's the interesting part. So we have an MySQL database, which is an SQLite database version. Open source, runs on Linux, going back to what I said about the Android platform. It's a Linux box. We have MySQL in there. It's not the full version, it's SQLite. It's a small version of it, and then the small version of it has basically no limitations except for the fact that you can't create tables that are going to be shared between multiple apps. So each app has its own view to the database, and the view is only available per each app. So Android uses a built-in, you don't have to install anything for it either. Not a content provider, it's a database. And I have a database program I'm going to show you maybe next Wednesday, because Monday we have to get through the internet stuff. So each database is private in the application. In principle, you can expose the data if you expose the application as a content provider. If you create your own content provider and it has a database, you've opened the door, which is nice. However, you've also made it so that other applications can access that data. So, all databases, SQL and other, are stored in a device, and it's in this particular data package name database. You can actually get at those database files by looking at your SD card, which is where it's going to be stored actually when you create the data. There's an interesting application, and this is part of the assignments that you have to do. There's a Notepad tutorial. One of the Notepad tutorials actually, which is on the Android developer.android website, is a Notepad program where everything is stored in a database. You can get to the example by downloading the API samples and creating a project and select Notepad, actually, and you'll see it. Useful database helper class and access for CRUD details. Creating, reading, update, deleting, which is what CRUD stands for. Most of the database applications have an activity. They have a database helper. The helper performs all the database stuff. The activity makes a new instance of the helper object, uses the helper object to manipulate the database. If you separate out the functionality, then you can perfect the helper, use the helper in multiple different programs. It's always the same. It's just a different table that you're creating, or it's a different column set. So if you download and look at this Notepad tutorial, you'll kill a couple birds with one stone, because you'll see the database connectivity, and it'll also help you kind of visualize and work with one of the assignments that you actually have to do for this course. And on Monday, I'm going to go through all the assignments to make sure that you guys are up to date with what it is you need to turn in very soon, actually. So context menu. We already went through the context menu. Why is this in here? Well, let me just go through it because it's close to the end of this lecture. I thought this lecture was on probably location and something else, menus or something. We looked at the context menu. I don't know the logic of this. It is special. It requires context menu, holding down the key. We looked at this actually already. When you press down on your finger long enough, the context menu comes up, or if you press the mouse down long enough, it stores locations to databases within the application as objects. That's why it's in here. The context menu actually works as a mini database for you, because it will actually provide lookup for you. Because when you click on items, it will bring you to the appropriate item selected. And it's sort of like doing a query on a database. So a lot of people would use a context menu to organize large sums of data. If you think about the contact list, it's a context menu, because each one of them is alphabetically organized, and you can scroll through an entire list of contacts that's in this content provider. So a lot of context menus are using databases as the backbone to keep the data in there. So Android uses the database helper class with SQL as well inside of its own implementation of all of the different features that come with the API. So part of the DB helper class is showing the location object. So here we have a location that's part of the DB helper, and it's running through looking at zip code, city, state. We actually haven't talked about location yet. We're going to hit that coming up very soon. But locality is another thing that you can set on the phone and call location objects and change the location. So it also provides CRUD details, creating, reading, updating, deleting, things that you would do to a database essentially, to map objects to SQL. So you can basically take and store locations. In fact, this example is looking at locations for addresses. And if the location is actually there, you can have a context menu where you press on it, it brings up a map view with showing you directions to this particular location or something. I'm not going to go through this code because I have a better example I'm going to show you on Monday that uses a database application, and I have a better locality example as well. So SQLite provides advanced database features as well. Well, actually I would say advanced, normal, whatever you would imagine existing on a regular database application. There is transaction support, which is with the J2 Enterprise Edition. The EE edition actually gives you a transaction monitor, transaction managers. The Android actually supports that as well. So you can use prepared statements based on the SQL. If you don't know anything about SQL, you don't know about prepared statements, you don't know about JDBC, don't worry about this. But if you do know about the Java EE and the JDBC, all supported. So you can have apps that run that use and create JDBC with prepared statements and stuff that actually go and connect to a database that's not on the phone and do queries and send information back. And it's like all of the advantages of JDBC on a phone running through an app. But you'd actually have to know something about SQL and JDBC in order to make that work. So use the prepared statement is also supported, sets the items that are done. In fact, you can use the prepared statement and you can use the JDBC connectivity for the database that's on the phone as well. It doesn't have to be external. But usually prepared statements are done to minimize traffic on a network. So you send a statement over prepares a generic statement, and you just send it variables. Select star from this publisher. Okay, no, that publisher. No, that publisher over there to get a list of books or something. So you have a cursor to keep track of the location within the result set. The cursor is supported as well. If you don't know what a cursor is, don't worry about it. But it's a database term to say, temporary memory, essentially. It's generally on the database end of it. So imagine you have a database server on the phone, and your app is connecting to this database server. And it's performing SQL queries and creating tables and doing everything that you would on a regular old client-server database environment. So you can map objects to the database as well. You can read items from the network as XML, convert to objects, which mapped to the database as well. GUI objects, data objects components. Enables off-network use and can sync later when connected. You can queue up a bunch of responses to something, messages, connect, so you don't have to actually keep a constant connection. You can use the database to actually support that functionality. The database actually supports large binary objects as well. So you can put images, files, all sorts of media inside of that database as well. So you can kind of create your own content provider that's private to your app using the database, which is how the Notepad example actually kind of works. It creates text messages and it puts them in a database entry, and it's only available through your app because the database is only visible through the app. If you use a content provider for that, everybody on the phone can see it. All the apps on the phone can look at the content provider. So, might be pushing limits of the device through the extra classes and the memory usage. Yes, if you use the JDBC connection, prepare statements, heavy-duty SQL, large binary objects, you're going to have a very slow-running phone while that app is running. It's very memory intense. You're doing things that would happen on a regular old PC, but you're doing it on a smaller processor, with a smaller memory footprint. So in summary, you can use preferences for each one of your apps. Preferences are, in fact, this list kind of goes in order of lightweight to heavyweight. If you just need to store something simple, create a preference and set some information. When your app loads, it loads the preference, gets the context view, loads the preference. There you go. It's kind of lightweight. If you need to store some heavy-duty data beyond preferences, maybe paragraphs of data, statements, I don't know, something, then you can read and write files to Java. You can ship the app with the file. You can create the file after the app ships. You can use the data inside of the app space that's stored to hold the file, or you can hold the file on the SD card. If you hold the file on the SD card, you have more flexibility and more space, more memory. You have that entire SD card to fill up if you wanted to, which is probably not a good idea because your user was not going to like you if you fill up SD cards. But if you haven't noticed, a lot of web applications, a lot of things that download music, download files, if you look at your SD card, you'll see all the junk that's left over from downloaded songs, downloaded pictures, everything your app didn't clean up. So let's see, you can have persistent read items. You can keep persistently read items over the internet when available. So if the user has an internet connection, you can store all your information on the internet and they can just download the stuff. And actually, you don't even know that they're downloading it. They don't know that they're downloading. You click on a button, it goes to the internet, grabs it, brings it back. Just like that the image file does. Or you can use SQLite, one database per app, and you can store data in the database. If you're going the SQLite option, you're really creating heavy-duty overload. I mean, that's like overkill for preferences. But, it depends on what you're doing as in terms of where you're gonna need the data, why you're gonna need it. Okay, thanks for staying a little bit later. It's not that much later. We're done for today. I get through everything I got to go through. So Monday, we see example after example. I got the image download. I got a couple of examples for you. I think Wednesday we started with SMS messaging and some other features. So have a good weekend. If you are not doing anything on Saturday and you're bored, come to the iPhone workshop. It's free all day long. Especially if you're taking the iPhone class, it might not be bad. I'm going to go through mostly design and storyboard features of the 5 SDK. A little bit of tutorial on Objective-C programming, differences between Objective-C and C++. Building some small apps, nothing too heavy, but it might be interesting if you're going to take the iPhone class. It's kind of like the get ready for the iPhone class kind of thing too. So, okay, maybe I'll see you Saturday, maybe not. All I have to do is show up. You don't have to sign up. So.